Hi, this is Shunji. My topic is about Beta-MPT, a Bayesian hierarchical model for learning cognitive events. So in class, we talk about latent class modeling. So given the procedures of a decision making, we learn how many outcomes there are. However, what if we want to learn the structure of certain decision making process given the outcome categories? Then we can use MPT, a powerful tool in the field of cognitive science, cognitive psychology that models and helps to analyze latent cognitive processes. So before we go into the mathematical aspect of it and also the example, let me just introduce the binary tree real quick. It is a useful tool for modeling the latent decision-making process in cognitive science. And each theta on the graph denotes the probability of making certain decision and can be regarded as a parameter as they are crucial in determining the outcome decision category. So our example, like two high threshold sort monitoring model can be regarded as a more complex binary tree. In a typical source monitoring experiment, participants learn a list of items presented by two different sources. And after that, the participants are asked whether a particular item is presented by source A or B or new source. If we just look at tree A, then its parameters are listed above. So if we're given a data set with structure like this, how can we model it? Well, since every participant will make a decision out of the given possible outcome categories with certain probability, we can use multinomial distribution as our data model. And for multinomial distribution, there are two parameters. One is the frequency and the other is the probability of getting each outcome category. Well, the former one is easy to get. The other is a bit tricky, but we can utilize the structure of a binary tree. As shown here, we obtain each probability by calculating the probability of getting a branch that ends with that category and multiply all of them. And then we can set up our Beta-MPT model. And since theta denotes the probability of a particular cognitive event, so it ranges from 0 to 1. Therefore, we can assign theta with like a weakly formative prior, beta prior, and then see how it goes when the model runs. To implement MPT methods, there's a R package called TreeBUGS, and it is actually pretty similar to RunJax, but since the data structure is multinomial, so it's slightly different. And for the rest of my presentation now, give you some idea of how TreeBUGS works.